Alright, so this will be a video just about section 2.4. I'm thinking about experimenting about just making videos focusing on a specific section of the book. So far I've just been doing, I've been doing it by homework assignment. So this is on homework 4, but it's section 2.4. So, right. This is about the definition of limit. And to talk about the definition of limit, we have to talk about these numbers, epsilon and delta. Well, I guess this one doesn't have an epsilon. I would say this is like the value of epsilon that we're using, but if x is going to a specific number, then what we have is the absolute value of x minus that number being less than delta. And that's supposed to mean that f of x is close to the number that it's going to. Like, this is a scenario where we're sort of assuming the limit as x goes to 2 of f of x is 3. Oops. Meaning that if x is close to 2, then f of x should be close to 3. And this is just one expression of how close does close really mean. If I want f of x to be this close to 3, meaning the difference between f of x and 3 is at most this, then how close does x need to be to 2? And so for the purposes of these questions, you're going to be given a graph. And we just have to read it off of the graph. So what we have here is this graph of f of x, and here's 2 on the x-axis, so we're supposed to focus on values of x that are close to 2, and here's 3 on the y-axis. But, right, going back to what we're really trying to answer, I want f of x, I want the difference between f of x and 3 to be at most 0.3. What that means is that from 3 I can go a distance of 0.3 up or a distance of 0.3 down. So if I go up I get 3.3, and if I go down I get 2.7. And you're going to see these horizontal lines from 3.3. Like, it goes out to where it meets the graph and then down. And also a similar one from 2.7. It goes horizontally until it meets the graph and then straight down. And we see that if this line lands at an x-coordinate of 2.2 and this line lands at an x-coordinate of 1.7. So in the end, this is going to be extremely easy. I'm just trying to explain to you why we do what we do. The question is, how close does x need to be to 2 in order for f of x to be in between here and here? In between here and here. These are all the things that are a distance of at most 0.3 away from 3, either by going up or by going down. So once again, I'm probably repeating myself too much, but how close does x need to be to 2 in order for f of x to be between here and here? Well, to answer that question, you have to think, when we're talking about how close x needs to be to 2, x could be bigger than 2 or it could be smaller than 2. X could be bigger than 2 by how much? Based on this picture, x could be up to 2.2. So I'm going to write, it's bigger than 2 by 0.2. And that's my interpretation of 2.2. Or smaller than 2 by how much? Well, it could go down to 1.7, so I would say that's a difference of 0.3. So that would be smaller than 2 by 0.3. To make a long story short here, you just take the smaller of those two numbers. Delta would be 0.2 because that's the smaller of these two numbers. In other words, if I go out a distance of 0.2, it doesn't matter which direction I go. I can, if I start at 2, and if I go a distance of 0.2 to the right, I'll stay within this range. If I go a distance of 0.2 to the left, I'll also stay within this range. Of course, I could go farther than that to the left, but the point is, I want to choose a distance that I could go in either direction, meaning I choose the smaller of these two. So in the end, if you take anything, I probably over-explained this, but you just take the smaller of the two numbers, and that's your answer. Okay. For the next one, actually, sorry, I just realized I have to. This is one where a graphing calculator is recommended. And it's going to be conceptually much the same as what we just did. So I have to use Maple, which is similar to a graphing calculator. So, sorry. I'll show you what's going on the screen in just a second. Oops, let me... Okay. So this is Maple. It's a computer program, but it can do everything your graphing calculator can do and more. Okay, so, sorry, I was not very prepared for this. Here's the problem. For this particular limit, the limit as x goes to 0 of this, we're claiming is 3. And there's no reason why you should see that this is true yet. This is something that we'll justify later, but this is true. So if you can just accept that for now, we are going to find a particular delta for a particular epsilon. So the epsilon we're given is 0.2, and we would like to find the largest possible delta that we could use to that, and we're going to round to 3 decimal places. So what I have here in Maple is I put in that function. By the way, that this is how you put e to the 3x into Maple. It's this exp of 3x. So I put that function, and it looks how you would expect there, into Maple, and I just plotted it. And one thing you should notice is here's x equals 0 around here, and it looks like we're going it looks like the y coordinate is about 3, which it is. Actually, the graph should have a tiny hole in this point, because you can't actually plug in x equals 0, right? This formula, it has x in the denominator, so you can't plug in x equals 0. So the graph should have a tiny hole, but on Maple we're not going to see the hole. It's very tiny. But the point is, we can see this looks like it's a y coordinate of about 3. So then it's believable that the limit as x goes to 0 is 3 by looking at the graph. In any case, how do we answer the question? What I need is I need this to be in between. I need it to be within epsilon of 3. In other words, I need to be less than 3.2 and more than 2.8. I took 3 and I added epsilon for this, and I took 3 and I subtracted epsilon for that. So what we're going to do, this is not an equation that we're going to be able to solve. We're just going to use Maple, or in your case, use a graphing calculator to estimate values of x for which this is true. So why don't I, and this is just kind of like guessing and checking here, frankly. F of, let's see. Actually, before I even guess, maybe I can narrow down. I can draw a better graph. So I'm gonna draw a plot that goes from x equals -1 to 1. So the window is just going to be a little bit smaller. Yeah. And then why don't I find? So here is the 0.03, and then I want to see when does this line go above 3.2. So I see it's on its way up. So what happens if I plug in a value of x that's just a little bit bigger than 0, like maybe 0.1? Whoops. Yeah, then it tells me it's this. So I have to, oh, there we go. Yeah, sorry, I fixed the problem. There we go. I did f of 0.1, and I got 3.49. Well, that's too big, right? I wanted this to be between 2.8 and 3.2. So I probably chose a value of x that's too big. So I wanted to choose something that was close to 0, but maybe that wasn't close enough. Let me try 0.01. Okay, that's in the range. That's good. But what I need is the largest value of delta. So what I'm going to do is I'm going to play with the value of x until I get something that's almost 3.2. This is smaller than 3.2, which is good. That's what I want. But I want something that's close to 3.2. So I keep playing. What if 0.2, I got 3.09, that's still too small. If I do 0.3, I get 3.13, still not big enough. Why don't I jump up to 0.05? Okay, now that's too big, 3.23. 0.04 is 3.18. And I want 3 decimal places. So now I'm going to start playing with that third decimal. So what if I do 0.045? Okay, so this is just a little bit bigger than 3.2, but I want it to be smaller than 3.2. Why don't I try 0.44? Still too big. 0.43, this is probably going to be it. Oh, still too big. 0.42. I'm going to keep going down. There we go. So for 0.042, I got a number that was smaller than 3.2. But if I went any bigger than that, if I went 0.043, that's the last one that I tried, and that was too big. So I learned something. X could be as big as 0.042. Or as small as, and now I'm going to fill in the blank. So what I just did is I plugged in some values of x until I got something that was slightly smaller than 3.2, and I went out to 3 decimal places, and I chose this as big as possible such that I still get a number that's smaller than 3.2. Now I'm going to do the other side. I'm going to plug in values of x. I want an answer that's bigger than 2.8, but I would like it to be close to 2.8. So this should go similarly. Now that I have this set up, now I'm going to plug in numbers that are smaller than 0. So why don't I start with negative negative 0.1. I feel like that's going to be too small. But let's see. Yeah, I got 2.59. I wanted something that's bigger than 2.8. So I should choose something that is closer to 0. Something closer than 0 might be like negative 0.05. Okay, this is closer, but it's still, I want it bigger than 2.8. So I go over here. This needs to be even closer to 0. So maybe 0.04. All right, good. Now at least it's bigger than 0.28. But I want 3 decimals. So I have one more decimal to play with. So now the question is, could I say like 0.41? Does that work? Yeah, that's still bigger. Maybe I should jump around more. 0.45, that's still bigger than 2.8. 0.46, still bigger. 7. 7, now it's smaller than 2.8. So that's no good. So 0.047 is no good, as we can see, but 0.046 was good, so that's what we'll go with. So x could be as small as negative 0.046. Okay, so there's a lot of playing with the calculator, or in my case, playing with Maple for this one. But now we basically know our answer. And this is based on the same logic. In the last one, x was going to 2, and I just looked at how close these numbers were to 2. In this one, x is going to 0, and the range of x's that I got was from here to here. So this one, how much bigger than 0 is this? This is a silly question. It's bigger than 0 by 0.042. How much smaller than 0 is this? Of course, this is smaller than 0 by 0.046. And delta is the smaller of those two numbers. I guess this one's slightly smaller. All right. So actually, that took longer than I thought. So let me just stop this video and restart it.